Let's do this question to prove that for natural number n, where this is your given matrix, you're multiplying the given matrix, this given matrix n times, the one that I've highlighted n times, raised to the power of n means I mean multiplying n times to get this. So what I have done, I have sub in n is equal to 1 on the LHS. I get this result 10A0. Then I have sub in 1 on the RHS. It's 101 times A1. So it's 10A0. So LHS is equal to RHS, right? N is equal to 1 is true. Now what I have done, I have assumed n is equal to k is true. I have got this. Okay, wherever n is there, I have just sub in k. Now I have written the step 3, like step 3 says n is equal to k plus 1 wholes. So we need to prove this, and it's mandatory to declare what you want to prove in k plus 1 step. Now let's go ahead. So now your LHS is 10A1 k plus 1, right? So it's k plus 1. It means, can I write it like this? You are aware of the indices, right? If I have a number, let's say b to the power of m plus 1. So that just means b to the power of m times b. That's what I'm doing over here. I'll be breaking it. So it will be 1, 0, a, 1 to the power of k, then 1, 0, a, 1. Okay, from star I'll sub in. It will be k, a, 1, right? Now 1, 0, a, 1. So this matrix I'm getting from star. So now what do you get by doing the matrix multiplication? This with this will give you 1. Then this with this will give you 0. Now for the next one, this with this, check, it will be KA plus A. Now again the last one with this one, it will give you 1. So this becomes 1 K plus 1 A 0 1. This is equal to your RHS. Okay. Now what we can say, therefore n is equal to k plus 1 wholes. So n is equal to k plus 1 wholes. Then what we can finally write down, this implies given statement is true for all natural number n, right, by mathematical induction. By mathematical induction. I hope this problem helps you. It was a different question, that's why I have included.